equation. And so when I say equation, that means there's a little bit of math involved, right? Okay, so don't get nervous because it's pretty simple math. Okay. Okay, so let's go on here. The wave equation. Okay, so this is the first wave equation. Look right here. The speed or velocity. You remember what velocity is? You know what speed is, right? That's how fast something's going. Velocity is how fast something's going, but in what direction also, right? Up, down, left, right, east, west. Okay. So the speed or velocity of an object in motion can be found by taking the distance it travels divided by the time it takes to get there. So speed equals distance what? Divided by time. You know, anytime you see a fraction, that means you're going to divide something, right? So speed equals distance divided by time. Okay, and then we're going to talk about this wave velocity can be found in a similar way. So I want you to write that formula down right now. Speed S equals d divided by time. S is speed, right? And right above your formula, I want you to write the word speed. Look here, right like this right here. You at home, you get a sheet of notebook paper or a 3x5 card. I gave these guys a 3x5 card. And write this formula down, and it'll help you here with some questions here in just a few minutes. So, so this is your speed formula. Oh boy, what in the world here? Huh. That's kind of weird. Okay. Hang on a second here. Okay, so you're going to write speed right above that. Everybody got that here? Okay, so let's take a look right here. Okay, so again, we're still talking about the wave equation, and the distance a wave travels. Look here, here's your wave, the wave, right? From the crest here to the crest there. So the distance a wave travels can be measured in wavelengths, right? Are you with me, Jalil? I need you with me.
Yeah.
And the symbol for a wavelength is the Greek letter lambda. Okay, it looks kind of like an upside down Y, right?
Mm-hmm.
That makes sense? So there it is, an upside down Y. And the time it takes a wave to travel a full wavelength is the wave's period. Okay? It's a period of time, right? It's a period. Okay? The symbol for period is T. Okay? T. Okay, so the wave velocity can be calculated by dividing the wavelength by the period. Okay, the wavelength by the period. So you've already got this one right here, right? Speed equals distance divided by time, right? Am I right? That's a small t. And then you've also got velocity. That's a speed in a certain direction. So this is the second formula here. And I want you to write this here. Mr. Hughes is going to have to look at the ink on this here. Speed. Uh-oh, Mr. Hughes. Okay, so let's try this again. Let's try the purple. Boy, I'm losing my ink here. That's weird. Speed equals, or I'm sorry, it's not speed. Oh, Mr. Hughes. My transparent looking ink is concerning me. Okay, this is velocity. Velocity. Velocity is speed in a certain direction. Everybody remembers that, right? Okay, so velocity equals, what is this? The wavelength. Volume equals the wavelength divided by the period. Okay, whatever the wavelength is, however that measurement is, divided by the period. Okay, and the period is the time, capital T time. Okay, Okay, got the idea?
Yes.
Okay, so let's, that is weird. Okay, so, I'm gonna move on here. Okay, hang on one second here. Let me look at my settings here. Hang on. We don't want a transparent background, do we? Okay. We don't want the transparent background, do we? No, we don't want the transparent background. So, let's go back over here. And let's make sure we got let's see what we got here. I'm gonna try to fix this, because this is a little bit blurry, it seems to me. That happens sometimes just happens. Let's see what else we can get right here. Okay, so we're gonna go on here. Okay, so let's continue on here. Okay, now, what is the velocity of a wave that has a wavelength of 6 centimeters and a period of 2 seconds? Get your calculators out here, okay? What is the velocity? So we're looking for velocity, right? Velocity. I'm gonna help you out a little bit here.
No, it's not.
I'm gonna help you with this problem here. Mr. Hughes, oh, here we go. Mr. Hughes is gonna help you out here. I see my issue here. Okay, Mr. Hughes. Okay, this is Veterans, this is the day before Veterans Day, and we're wearing purple. So let's use the purple ink. So let's do this problem together here. So volume equals, or velocity, I'm sorry, equals what? A wavelength divided by the period, right, of 2 seconds. So here's our problem here. The velocity equals what? What's the wavelength? 6 centimeters, and then what is divided by 2? Okay, so what is our velocity? What's our velocity? 3 what? 3 cms per what? Seconds, right? Okay, I think we're gonna use that here. Does that make sense? Okay? Okay. Let's move on. Well, let's double check that. Okay? I'm gonna have to get rid of the ink just to make sure. What is it? 3 centimeters per second. Were we right? Yes, we were. We were correct, weren't we? Okay? Got the idea? Okay, for you at home, just write in this area here what you just saw me write, okay? Okay, you can stop the video, write it out on a sheet of paper. You can actually put it on this too as well, okay? Use your Cami and write the velocity equals wavelength divided by the period. Okay, let's move on here. Okay, so now you gotta, let's look at some more wave equations here. So we did this one right here, right? Okay, so a more common way to calculate wave speed is to use the number of vibrations per second or frequencies instead of the time it takes for a wave to vibrate one, okay? So you can get the same product here by taking your velocity equals and then multiply your wavelength, which in the case of the last problem was 6 centimeters, right? That was the wavelength. Times